I'm going to start with this is the cover of the book, The Imperishable Seed: How Hindu Mathematics Changed the World and Why This History Was Erased. And today, I'm hoping Dr. Kamble will shed light on both of these topics for us, how it changed the world and why the history was erased. Let me welcome Dr. Kamble onto the talk and screen, and maybe just start off by saying, how did you end up writing this book? What prompted you to pick up this topic? Your field is physics, which of course has a lot of mathematics in it. But what was the inspiration?
Yeah, I was using mathematics, of course, as a theoretical physicist. Cannot that is integral part of physics, and so but I was not really concerned with the history of mathematics as such, and so I always had this. I always had this impression that okay, mathematics comes from ancient Greece, and then it was developed in Europe during the Renaissance, and after. So this was my notion, and then sometime in 2009 or 10, when I was still in my last days in IIT Kanpur, I heard from one of my friends that the so-called Pythagoras theorem is given in the Sulba Sutras, centuries before Pythagoras. And at that time, I dismissed this. I thought that this is simply right-wing Hindu right-wing propaganda somehow, because this was my whole conception of the Indian civilization, that it was about caste discrimination, and then there is this bunch of people who keep on claiming that everything comes from India. So I dismissed this at the time, and it was only later, 2011 or 12, when once I had finished my PhD and I went to Bochum in Germany for my first postdoc. I happened to read an article by a mathematician called John Playfair, written in the end of the 18th century, and he discusses some ancient astronomical tables which came from India, and there he discusses the methods which they used for calculating the duration of an eclipse, predicting when the eclipse occurs, and there he says that the Indians used this result, which is known today as the Pythagoras theorem, centuries before Pythagoras lived. And this was for me very unsettling, because obviously this John Playfair was not one of those Hindu nationalist right wing guys, right? So this was obviously like coming from a totally independent source, which showed me that okay, that I had been wrong about my assessment about Indian mathematics. And then I thought that okay, if I had been wrong about this so-called Pythagoras theorem, about which other things could I have been wrong? Like I wanted to then look at this further, which other things did I have a wrong knowledge of or missing knowledge of. And I wanted to do it also properly, in the sense that so I went through a proper systematic survey of the literature, research literature on Indian mathematics, on the history of Indian mathematics, because in the university that time it was also freely available to me as a researcher, access to the research articles, journals, and yeah, and in those days also this information was not so commonly available online, which like today there are many people on Twitter, for example, on social media, who share this information. In those days, 2010-11, it was not so well known. So I started reading about this in detail from the research articles, and then I wrote a series of blog posts based on which is like the nucleus of the book, the way it finally took shape. And for me also, what was really interesting, that on the one hand, okay, this knowledge of mathematics is there, it is hiding in the research articles, in very specific places, academic places. But in the general public, in the general population, there seems to be no awareness of this. People are totally, absolutely ignorant of this. People may know of Pythagoras, even though there is no evidence that he discovered the theorem or that he proved the theorem. People may know of Newton, of Gauss, but people hardly, when it comes to India, the most that people know is that okay, the zero and the number system, if at all. And in Germany, even that is missing. The people think that the Arabic numbers, they come from Arabia, educated ones even. So this was for me also very interesting to understand, okay, why this ignorance exists. So what are the factors which make this ignorance so strong? and and at the same time, around I think, I don't remember exactly when, maybe it was around 2013 14, I also happened to read the books, the writings of Rajiv Malhotra. So one book which had a huge impact on me was Being Different. So there he speaks about the notion of Western universalism, and how this is used to subordinate other civilizations, other cultures. And this for me also was a very impactful book, because I saw the same tendency in mathematics. If you read any book on the history of mathematics, general history of mathematics, uh, if Indian mathematics is mentioned at all, it is mentioned just as a footnote, as a footnote to the grand edifice of Greek mathematics, of European mathematics. And the message always is that, okay, the Indians may have done something, but the right way of doing mathematics is only given by the West. So these are the things I noticed. Okay, I connected that with mathematics, with what I read from Rajiv Malhotra's works. And the other big inspiration for me were the writings of C.K. Raju, where he discusses about the transmission of calculus from India to Europe. And this was also for me a huge turning point, because as at school, in the university, calculus is one of the most, I think, the challenging subjects in mathematics. And there is this this huge awe of it, that most students feel when they hear of Newton, Leibniz, and the people who developed, supposedly developed calculus in Europe. So it was like all my notions of history were coming tumbling down. And so I just kept on reading more about this, collecting my thoughts, jotting my thoughts together, and then finally I wrote a first version of the book, which I self-published. I think it was 2018 or 2019, something like that. And this I've self-published, and then this is the version I also sent to you, to Garuda, actually. And and then after that, of course, I got your email after some time, saying that, yeah, this is a very nice publication, we would like to publish it, but we should do some changes. And so began our editing process of improving the book further, restructuring, and so on, and your inputs, and then yeah, our discussions, etc. They also, they had a, yeah, they really improved the book, structure wise and everything. So this was the
Yeah, it was
story.
a really fun process for me. From a Garuda point of view, we get so many submissions, and some of them we have to pass, and some of them are uh, something that we want to publish, and then some really spark my personal interest, because there's so many books I don't end up reading many of them myself. But this particular topic, since it was of such great interest to me, I started reading the book, and I consider myself having a little bit of knowledge of the subject, not an expert by any means, but there were so many things I was learning as I was reading the book. And one of the things that struck me, actually two things that struck me very distinctly. One was this, a lot of times we hear this thing, oh, India invented zero, and we don't even understand what is the significance of invention of zero, and how does it matter if India invented it? Anybody could have invented it, right? So one of the things that I'd like Bhaskar to talk about more is the fascinating part of the book is how he relates the invention of so many mathematical ideas, and the whole series of mathematical ideas actually come from India. Firstly, that was a surprise. Trigonometry comes from India, algebra comes from India, all of the arithmetic that we do practically comes from India. But how they were tied to Hindu philosophical ideas, and in fact they could not have emanated anywhere else, because there was a whole philosophical foundation that was needed for those ideas. There was a cultural foundation that was needed for those ideas and concepts to develop. So that's one thing I really want you to speak about. And the other is this notion of Hindu mathematics. I know we had a lot of tussle and debate on this. Shall we call it Hindu mathematics? Shall we call it Indian mathematics? And I think that's also related to this question as well. So definitely like to hear from you about those.
Yeah. So this is a very interesting point that you brought up. That this is actually one of the main features of the book, that how the mathematics in the Indian civilization, it relates to the deeper knowledge framework and the philosophy of the Hindu civilization. So so in fact, I have devoted chapter 2 of my book to this to the knowledge framework and philosophy of the Hindu civilization. Um, and Yeah, so actually there are so in the general conception of knowledge, of course, there is this concept of para and apara prakriti, in which you can say maybe consciousness or spirit is roughly, using the English word equivalents, not equivalents, but the English words are the so-called para prakriti, and the other one is apara prakriti, which is the material world, which consists also of the mind, emotions, and the ego. So which is a pretty subtle point to understand, because even they form part of the apara prakriti along with the material things. Uh, so so in this context, like in the West, there is this always this divide between like consciousness and matter and so on. Whereas in the Indian civilization, these both are, like, they are not mutually exclusive to each other. So in the sense that, like, for example, and so this is one of the frameworks of knowledge of in the Hindu civilization, which played a huge role in the development of knowledge. So it can be seen in many ways. For example, even the title of the book, The Imperishable Seed, it is like, so so it comes, the word for algebra, for example, is bija ganita or avyakta ganita in Sanskrit. Okay, so the word bija means a seed, and this is actually a reference to the notion of the avyay bij, for example, which occurs in the Bhagavad Gita. And the idea is that if you use symbols for expressing a general relation, that symbol contains all the cases, all the concrete cases, all the so-called vyakta instances of this one particular principle. So for example, in a right angle triangle, if you say that a square plus b square is equal to c square, this relation contains all the right angle triangles that can be there. So it's like, this relation is like, if you use symbols, it is like the avyakta, and the particular cases of this will be vyakta. So algebra, for example, has a very deep connection to this notions of vyakta and avyakta in Hindu philosophy, and this is what I have explained in quite some detail in my book. And when it comes to zero, the notion of using zero was really something which eluded the Greek civilization for centuries. And even when Europe came into contact with them, it was totally foreign to it. It took centuries for it to understand that. But in the Indian civilization, zero was like, if you read the words of Brahmagupta, zero was like, it's like the sum of two different quantities, like positive quantity dhana and rina. Dhana would mean wealth, and rina would mean depth. So if you add equal amounts of wealth and depth, you would get zero. So so Brahmagupta formulated the concept of zero in the concept, with the concepts of dhana and rina, that is wealth and depth. And this is something which was also not comprehensible for the earlier civilizations, for European civilizations, because numbers were connected with physical quantities like length or area, which can never be negative. So these are, I think, some of the points that come up in the study of Indian mathematics.
Absolutely. And then, we were also talking about this notion of Hindu. Firstly, it's related to Hindu philosophical ideas, but also, of course, there were a lot of contribution from Jaina mathematicians, from all of those, which you
Exactly.
also acknowledge. So you're taking it more as a broader civilizational
Yeah.
term.
Exactly. I use the word Hindu as an umbrella, as a term for including the Jain, Buddhist, and all the streams which existed in India. And I it's separate from the word, from the religion Hinduism, because the religion Hinduism is a different thing. But this Hindu mathematics relates to the geographical and the civilizational aspect of it. And I avoided the use of the term Indian mathematics, because India is a country, is a political entity which has a very fixed beginning in 1947, and this also excludes a lot of areas which were originally historically part of the Indian or the Hindu civilization. So these are two things. And yeah, and also Hindu mathematics is something which is also like used in academics. It is standard terms. If you look at the academic writings on Indian mathematics, it's a very standard term till yeah, Datta and Singh. If you look at writings of Datta and Singh, and
Absolutely. And the numbers have been called Hindu Arab numbers, for instance.
yeah,
You know,
exactly.
that's
And
the
you're
common
right.
the
Yeah,
common scientific term for the numbers is Hindu Arab numbers. Of course,
yes,
as we learn in the book, um, again pitching for the book is called The Imperishable Seed by Dr. Bhaskar Kambale, and it's available at garudabooks.com. So in the context of the book also, we have this Hindu idea, both philosophically as well as civilizationally, being present in that and encompassing, all of these ideas. But there's also, one of the interesting things you just said is that it took Europe. Firstly, the Arabs were quite open about the fact that the knowledge that they are talking about came from Hind, right? So this is what Al-Khwarizmi's book, talks about. But then it took Europe. Why did it take Europe 200 years to understand zero? What was so special about understanding zero? Isn't it kind of obvious?
yeah. Actually, I think it's a very yeah. So there was a huge competition between the so-called abacists, the people who were using the abacus for doing calculations, and those who were trying to learn the new number system from the Arabs, the Indian numbers. So there is historically, many people have claimed that okay, it was because the church had a role to play in this, in the sense that these numbers were called as infidel numbers, and they come from a so-called pagan land. And so they probably there was also some religious prejudice against the use of these numbers. This could be one factor that that seems to have played a role in the hesitation of Europe to use these numbers.
Absolutely. Absolutely. And there's these two terms that you used, which is the abacus users and then the algorithmic users. And this is again a very, very fascinating aspect that comes out in the book. And I don't know if we realize the import of it. So just to clarify again for the people who are listening, before India invented the decimal system, there was really no algorithmic way to do computation. So for instance, if I give you a number like 6,532 and I say go ahead and multiply it by itself, take the square of that number, today you would write those numbers next to each other, and you would have a method, an algorithm by which you multiply one row of numbers and then you add it, and there's a method by which you do that. Now if I told you to do the same thing, write 6,532 in Roman numerals, and then I ask you to multiply it by itself using Roman numerals, how would you do that? The answer is you couldn't. There was no method to do it. There's no system to do it. And so the revolution is not just because one invented zero. The next level is that you invented a place value decimal system so you could represent these large numbers. And not only that, then you created all the algorithms for how you do arithmetic operations. So all of the algorithms, the arithmetic operations we learn in school today arose from this mathematics and were actually present in these texts, right, Bhaskar? So these algorithms that we are using for multiplication and division and all of these are specified in these ancient texts of India.
Sure. Yes. Sure. They are all described how to carry out these algorithms. Yeah, these methods. Even the word algorithm comes from Al-Khwarizmi for that matter.
Right. Yeah, and that's the
Yeah.
other funny thing, which is that the word algorithm comes from Al-Khwarizmi, who himself calls his book Hisab al-Hind, right? What is the full title? And
Oh,
he
actually, I forgot. It's quite a complicated title.
yeah,
There were two
it's a
books. One
long
was
title,
on,
but
yeah,
basically he says Hisab of Hind, the
yeah,
mathematics
the
that
Hisab.
comes from, yeah,
Yes, Hisab. The book with Hisab is to do with arithmetic, and
right.
the book with algebra is called Al-Jabr. So Exactly. So both were, in fact, yeah. It's well documented that the mathematics of Brahmagupta and Aryabhatta, it went to the Arabic world. So I have also like discussed this in detail in my book, and then based on these translations into Persian and Arabic, Al-Khwarizmi basically, yeah, just yeah, let's say, like, put it into his own words, then the knowledge which
Right.
was there. And in fact, there are also he even regressed a little bit, in the sense of, that his algebra never uses any symbols. It's all rhetorical, it's all spoken in terms of words of language. He never has a single symbol, whereas the Indians used symbols in their algebra like we do today. Symbols for, yeah, like they would call it as, they would take the letters of the different colors, and they would name that, and then use them in the unknowns, or they would call them as yavat tavat was also one word they used, which means as much as. And yeah, and interestingly, even the Italian algebraists, Bombelli, I think they use the word tanto in Italian, which means exactly the same as yavat tavat in Sanskrit. So yeah, so
Ab-
yeah.
a- Absolutely. I think that's the other fascinating thing. When Bhaskar came to me and we kept on discussing the book, and he said, "Oh, all these equations were present." I was like, "No, don't tell me. Show me how they used to write equations." So we used to have all these challenges, and so he went back and found the text and found how did we represent equations. And we actually, the book will have all the details of how you actually represented equations in Hindu mathematics. How did you represent that in Sanskrit text? How, and of course, there was a lot of interplay of language representation of numbers as well, because the language itself would code numbers, and that's why you could write all these poems that could represent the pi, for instance, and all of
Yeah,
these things. So
yeah. So, for example, even the way the equations are written in the Sanskrit texts of Brahmagupta and Bhaskara, etc. So even there, you see this close interplay with the Hindu philosophical ideas of Vyakta, Avyakta, Rupa, Arupa, etc. So the specific numbers, 5, 6, -7, etc., they would be called as Rupa. So, and they would be prefixed with the syllable Ru, for which stands for Rupa. And so even here you see this close interplay with the Indian philosophical ideas of Vyakta
absolutely.
and Avyakta. Yeah,
So moving forward from, so we talked about the arithmetic operations, all the algorithms we do. Again, algebra, the equation, symbolic representation, all of those ideas come from India. And even not only does Europe take 200 years to understand zero, even the Arabs have a lot of difficulty with some of the concepts. For instance, they completely ignore negative numbers. Um,
yeah,
isn't it right, Bhaskar? They had a lot of difficulty
exactly.
with like negative numbers, and from a church point of view, and also from, they were also considered like bad, or satanic or something like that. Mm. So
Yeah,
it took a while for the Arabs to, and without negative numbers, you really can't have a strong grasp of zero, because Brahmagupta actually defines it with
exactly.
relationship to negative numbers.
Yeah, exactly. Yeah. So yeah, in this context, there was this one of the first European scholars who tried to understand numbers. He went to Spain. Was this Gerbert of Aurillac, Pope Sylvester, I think his name was, and he was yeah, he went to Spain for learning from the Muslims there about the Indian number system. And yeah, there is this, he got this bad reputation of conversing with the devil, of having practicing black magic, and then yeah, so there's this in this book Imperishable Seed, there's also one image of Gerbert of Aurillac in one of the Latin books, where he's shown speaking with the devil. So yeah, there was definitely this kind of a prejudice against non-Christian, so-called pagan sources, which actually is, colors the history of European mathematics to a very huge extent. I mean, even this whole thing of Greek mathematics, Euclid, Archimedes, etc., was this whole narrative was created during the time of Thomas of Aquinas, and after that. So and it was sort of, used as a method to not to, give credit to the so-called pagan philosophers, and to black out their works. So this is a theme in much of European history of mathematics.
Well, the Greeks were also pagans, though, right? So there's also some
Yeah,
racial elements involved
yeah, yeah,
in
yeah.
that.
This is so the Greeks were also pagans, of course. I mean, pagans, quote unquote pagans, because it's a derogatory word. But they were co-opted. Like Euclid, Archimedes, they lived thousands of years before these guys like yeah, Regiomontanus or Thomas of Aquinas. So they lived yeah, several centuries before the rise of Christianity, and so it was easy for them to co-opt into the narrative of Europe. And there's actually a very interesting, this Dante. There's this Italian poet called Dante. He has written a trilogy, Purgatory, and the Inferno, the Purgatory, and
Inferno.
I think,
Yeah.
yeah, yeah. So there he writes, how all these earlier Greek philosophers like Pythagoras, Socrates, etc., although they were pagan, they are not condemned to hell somehow. So you can see you can trace the history of how they are being co-opted into the Christian narrative from his poem. So yeah, so right.
I
And
think
then there were this later Greek philosophers, the so-called Neoplatonic Greek philosophers, start in the first second century CE. They were definitely considered to be pagan, and they suffered a lot of persecution at the hands of the Christians, and they had to actually flee Europe, and they took shelter in Persia. And in fact, their works then became the so-called Arabic, the Islamic Golden Age, which is known as the Islamic Golden Age.
right.
And it,
You also
yeah,
dismantle this idea of the Islamic Golden Age. I won't go into so much detail in that. But
yeah,
coming back to the history of mathematics, um, I mean, the book goes into a lot of things. If you want to learn how trigonometry originated, how even these terms sine and cosine, how they actually come from Indian terms and through erroneous understanding of Indian terms. Um, so we learn a lot of that. The story of Fibonacci is also very interesting. Just like what I see as a pattern is just like the original Arab translators were quite happy to acknowledge the Indian sources, but later on, it gets buried. And when the historians are writing it, they kind of bury the Indian sources. Similarly, with Fibonacci, also is very happy to acknowledge that he's just transcribing the mathematics of India, right?
yeah. It's very interesting. Even if I also cited several books from the 12th century or something. Some of the first books which came in England on the history of on the use of the Indian numbers. So even those people, they happily say that okay, these numbers come from India. I mean, there are some. So in those days, in the early part of the previous millennium, yeah, people were actually comfortable with citing it, with referring to the Indian sources. But then, yeah, this tendency takes over. Uh, and later on, of course, with the rise of colonialism and imperialism, this religious notion of supremacy then gives way to racial supremacy, and then um, it sort of gets co-opted into the narrative of racial supremacy during the colonial times. I mean, this is also this is one of the key points also that we discuss in the book. I discuss in the book in chapters 13 and 14. So chapter 13 deals with why did it stop this tradition of Indian mathematics in the Indian civilization, and chapter 14 deals with why we don't know about it. So yeah, these things are really important that people know about these things, why this stopped. So,
Yeah, absolutely. And this this thing that the mathematics change, the history of mathematics, how it gets talked about before India is conquered by Europe. Europe is more willing to acknowledge Indian sources, right? But as colonialism takes deeper and deeper root, and the need for establishing the supremacy of the European civilization over the Indian civilization, because Macaulay and others later on figured out that, especially after the 1857 War of Independence, that unless you capture the mind of the Indians and make them believe that we are a superior race, it's going to be very difficult to hold on to it. And so we see a whole lot, in the book, so many interesting examples of earlier Europeans acknowledging the Indian sources, and then later on, those getting erased or and they're raised on the flimsiest of grounds, like obviously, these are vile and conniving Brahmins, therefore they must have made all this up. Just absolutely bizarre reasoning where you ignore direct evidence because the Greeks are obviously superior and therefore they must have invented it. Those are the kinds of reasoning given for historical points to be made, whether we
Yeah.
should consider one or the other as the source.
Yeah, absolutely. It is actually quite shocking if one really reads the reasons they gave, and uh, but the sad fact is that these prejudices have persisted and even become stronger over the years. And yeah, this conniving evil Brahmins who created these dates of an ancient antiquity is also, yeah, it starts also from like Francis Xavier. He, what
Right.
he writes about the Brahmins, for example. In this context, I would like to show one slide. Yeah, so here in this picture on the left, you see a scan from one book by Roos Ball. He from his book A Short Account of the History of Mathematics. This was written in 1915, and this is the context of the so-called Aryan race theory, which also I've discussed in some detail in my book as to why one of the reasons why this history of mathematics got suppressed. So the Aryan race theory, was invented by the Europeans to claim ownership over the accomplishments of the Indian civilization, to claim that, okay, this was actually done by the Aryans, and this is whatever great we see in the Indian civilization comes from our forefathers who were the Aryans, and we, the Europeans, are the white Europeans, are the purest descendants of the Aryan race. So in the context of mathematics, you see it here in this slide, in this picture. So I have written the text on the right side, which is there on the. So he says, no science or useful art can be definitely traced back to the inhabitants of the Indian peninsula prior to the Aryan invasion. Uh, their descendants, the descendants of the Aryans, that is to say, not the original Indians, the descendants of the Aryans, wherever they have kept their blood pure, may still be recognized by their superiority over the races they originally conquered. So it means that, whatever good is there in the Indian mathematics, art, philosophy, etc., does not come from the originals as such, original Indians as such, but it comes from the Aryans, who are our forefathers. So their superiority over the races they originally conquered, but they gradually degenerated, but for the first 2 or 3 centuries they retained their intellectual vigor and produced one or two writers of great ability. And then he goes on to discuss these writers, and the first one of whom is Aryabhatta, so from the 5th century. So this is how you see how this gets co-opted into the narrative of the European supremacist project. So
Yeah, this is
yeah.
fascinating because like this Ball's history of mathematics and all of these were like the seminal works that define the field of the history of mathematics. So
Exactly, yeah.
you have these completely racist and also these notions of Christian supremacy and gospel truth. I think in one time Mill actually says these Brahmins are clearly like conniving and manipulative because they have such old dates, and we know the world is only created 5,000 years ago or 6,000 years ago. So obviously it's
Yeah,
absurd that these dates would be so long because they go against our Lord's
yeah,
gospel. So,
it's
so
obvious, no.
imagine the height of untruth that these Hindus have created, that they are making these dates that even go beyond the gospel.
Yeah,
And
yeah,
the real tragedy is that today's history of mathematics, one way or the other, builds upon those things, even though they won't say the same thing today. And we know that the Earth is millions or billions of years old, but the history of mathematics continue to cite these older sources, which have made all these assumptions as part of it. And so very few have actually the courage to go back to primary sources or to just overthrow or just throw away all of this prejudiced history that was written. And
exactly,
that's
yeah.
one of the sections of the book that's really interesting, which is why it was lost and then how the origin was erased. So maybe we can touch a bit on each of those ideas. Why is it that the Indian child of today does not? It's like we invented this, the Europeans took it, then they came back and told us you are a backward race, you don't know anything. To learn his mathematics or science, it comes from us. So learn it and become advanced. And we accepted the story. We forgot that we had created it and we accepted the story. So shed some more light on that.
Yeah. So, so in fact, this is really a rather perverse way of the way history has shaped out in the last centuries. I must say that you put it very well. This mathematics was appropriated by the West, and then they tell us, it came from us, and you are the backward fellows who learn from us. So, I mean, this is a yeah. In my case, I really have to think of the story of calculus, for example. This is one of the such a I mean it's also there in the case of arithmetic, algebra, and other things. They went to the West, to Arabic world and to the West, but of course, somehow the story of calculus is somehow which really touches me very close, because for a long time one just learn thinks that, oh, Newton and Leibniz, there is this whole mythology built around Newton and Leibniz. But then, somewhere down the line you learn that, okay, these things were discovered 3-4 centuries earlier in India. There were the Jesuits priests who were stationed in Kerala. They sent Sanskrit texts back to Europe, and Europe that time wanted to have the knowledge of the calendar. They wanted to have the knowledge of navigation because of colonialism and everything. And then the whole image turns upside down. So it is there are so yeah, so of course, like, colonialism is one of the factors which had a huge role. Religious supremacy also had a huge role. And with colonialism, and but when the religions started becoming less important, this was replaced the religious idea was replaced by the idea of race. So race was really a scientific thing. I mean, today we would call it pseudo-scientific, but it was really a scientific thing in the Europe of till about the 1940s and 50s.
So again, a reminder, the book is called The Imperishable Seed, How Hindu Mathematics Changed the World. And this is available from garudabooks.com. For international orders, you can write at international@garudabooks.com. Email us and we'll send you a payment link.
Yeah. So coming back, so this idea of race was given a scientific basis by huge names like Immanuel Kant. He wrote, for example, that humanity is at its greatest perfection in the race of the whites. It is written by him. Then from race, we of course had this illustration of the Aryan race theory, which we just saw some time back from Roos Ball's book. And for in the colonial time, it would have been totally, if you want to rule a country, how you cannot rule a country if the people know that their heritage, their civilization has been much more advanced than those of the invaders. So you have to really break their will. You have to break their whole identity of themselves. You have to convince them that we are the masters, we are your masters. And then this thing is and plant in them the idea that that we are doing you a favor by ruling over you. So this has been the sort of the modus operandi for ruling over any country or any people. And then I mean, then there is of course basically the whole narrative of Greek mathematics, which fits in so nicely into this project of European supremacy, and which even after the end of colonialism, this thing has really persisted, that Greeks were the originators of mathematics and Europe took it up further. And and only the Western way of doing mathematics is the right way of doing mathematics. And so I mean, so I would say that these are some of the factors which makes one
Absolutely
persist with the old.
So I think this is, as I said, a lot of times we have books on history of mathematics, but some unique things about what Bhaskar has done is, one is to, as I said in the beginning, bring out how this creation, a lot of modern mathematics that we study today, not only came from India, but was closely linked to the Indian philosophical and the Hindu philosophical traditions. And secondly, very few books on the history of mathematics actually go through the distortions that was caused in the history of mathematics and why those distortions were there, and why did we forget that all of this knowledge came from us, which is a very, very important aspect towards decolonizing the mind. And for me personally, I think this particular book is one of the strongest tools for us to share with our friends and other people in terms of decolonizing the mind. It's impossible to read this book and not come out with a sense of awe over what happened in India and what our ancestors had created, but also to have much more clarity over why is it that we've forgotten all about it. This is everything that was done, and we completely know. If you go to an Indian school child, they wouldn't know about this. Forget an Indian school child. You walk into somebody who's studying in an engineering college, studying in an IIT. Both Bhaskar and I went to IIT Kanpur, and I was trying to talk to my in my friends group of IIT Kanpur and saying, hey, there is this book, and there is so much apathy. There is so much like almost like, oh, we already know what the history is, and we don't need a revisionist account of it, even though it's completely supported by evidence. He's gone into the original text. We've replicated it. We've shown how earlier Europeans actually even acknowledged the sources that came from India, and this was only a post-colonial or rather a factor of colonialism that all of this was erased. So really, really encourage people to both get a copy of the book, but also gift it to your friends, especially quote secular friends who think all of this is bunkum and just some right-wing Hindus, creating false pride in history or things like that. Not only because it's important to tell the true history of colonialism and get out of that, but also, as C.K. Raju and other people's work has shown, getting back to anybody who's copying always also creates distortion. So Europe created a lot of distortion in the understanding of mathematics, in the understanding of calculus, in bringing this notion of proof, which discarded any sense of the empirical. Again, a very important point. Like science allows real world input, real world data to be used. You can conduct an experiment and decide whether something is true or not. But the mathematics that were theologized in Europe took out the notion of empirical proof as valid basis of knowing in mathematics. So you could only do proof through derivation, through axioms, and so on and so forth. So it's not only about realizing and decolonizing our mind and seeing how our knowledge was taken and its origin erased, and we were told we were backward, but also we will be able to progress much more further. The world will be able to progress further if we go back to the treasures and origins of how this mathematics actually came about.
These are very interesting. Sorry, I didn't.
Yeah, go ahead, Bhaskar. That was longer monologue than I intended.
No, it was a really interesting point you made, because when you speak about the methodology of mathematics, when we have this notion that the European way of the Western way of doing mathematics is correct, and it's the only universal, and this so-called axiomatic approach which leaves out the empirical, and it's really funny because this is the argument used in claiming the superiority of Pythagoras, or the priority of Pythagoras over the theorem, even though there's no evidence that he proved it or he discovered it. Okay, and then in the Shulba Sutras, there are in the constructions there are implicit proofs given in the constructions, which consists of some rearrangement of the shapes. You just you move one triangle to the other, and you see that the areas are equal of these two squares and this square. So this so-called these are dismissed as inferior proofs or methodology, and so, but the funny thing is that in spite of all the superior methodology of the ancient Greeks, like Euclid and Archimedes, about which it's also doubtful if they really wrote what is ascribed to them. We'll come to that later. But in spite of all their superior methodology, they could not discover the number system. They could not discover the idea of develop the idea of zero. And if you go forward a few centuries, in spite of all the superior methodology of European mathematics, it was actually Madhava, Jyeshtadeva, it was Nilakantha who developed the ideas of infinitesimals, and this whole idea of I mean, of course, not just they. I mean, to be very honest, to be very clear, the history of calculus goes back to the time of Aryabhatta with his sign tables of second order sign differences, and which I have documented in my book and given a detailed mathematical derivation of that. But yeah, so it's so in spite of the supposedly inferior methodology of the Indians, they are the ones who developed the ideas of infinitesimals and calculus, 3-4 centuries before they are, rediscovered in Europe. So this is something is really strange, that if the methodology is so inferior, how come it creates innovative mathematics?
Yeah, I think that's a really good point. Go ahead.
Yeah. And there was one more point you mentioned, that people these days just not aware of that this mathematics comes from India. In this respect, I think I would like to also share one of my personal experiences while Sankrant and I were going over the book and editing the books. So Sankrant, at one point you told me to find out the original Sanskrit verses which talks about the binary number system in the works of Pingala and the commentaries of them. So I really had a really hard time in looking for the original Sanskrit verses. I would find some books where there were only the original Sanskrit verses, and since my Sanskrit is not so good that I can understand everything just from the Sanskrit alone, I needed a translation. But I just did not come across any translation also of these verses, and funnily enough, it was from a German author, one German Indologist called Albrecht Weber, who had translated the works of Halayuda, who wrote the commentaries on Pingala's works. From where I got these these translations, because I happen to know German, which for me was very valuable in reading these old books, manuscripts of the German Indologists, and I got the translation of the Sanskrit verse, and I was really surprised that, okay, how come there are no English translations? And even in India, how come there are no books published which are the English translations of these works on prosody and linguistics by Panini, by Pingala? And this was also very surprising.
It's interesting you say that, because I remember talking to my friend Maria Wirth, who's written this wonderful book called Thank You India. And in conversation one time, she was mentioning that Indology was so huge in Germany. And if you look at in the 18th, 19th centuries, there are so many Sanskritists that are actually from Germany. And interestingly enough, she said that so many of the Pandulipis, the palm leaf manuscripts, were taken from India to Germany that we don't even have. And Germany was considered a scientific power at the turn of the 20th century. It was the foremost scientific power. And she was saying one of the reasons it became a scientific power was it had so much access to Indian knowledge that others did not have it, because they had invested in these translations. So there's so many parts of that. Just to touch on, the book also doesn't go into a great deal of detail, but it touches on very related ideas of the calendar systems and of astronomy that also is very much advanced in India, and how Europe borrows those ideas, and to the extent that I think the analogy that Galileo is giving is the exact same one from a Sanskrit text. Isn't that right, Bhaskar?
Yeah, exactly. So it was Aryabhatta who gave the example of this was in the 5th century. He gives the example of a boat to describe, like, the stars. When we see the stars, they appear to rotate in the sky. But he gives the analogy of the boat. When we go in a boat, the trees, etc., they seem to be going backward. It's not because the trees are moving, but it's because we are moving. So likewise, it's the
So
Earth which is
he's
rotating.
saying that the Earth is rotating, and
Yeah.
all of these ideas are there, and then Galileo, from all we know, uses the exact same analogy in his description. Now, did he just come up with the same analogy by chance, or? And we know there is
Yeah.
a whole lot of transmission of Sanskrit text that is happening at that same time.
In fact, Galileo was in close touch with the Jesuit priests who were stationed in Kerala. There's also a book Galileo and his sources. I don't remember the author's name, but in this book it is traced out that Galileo was in close touch with the Jesuits, and he learned a lot from their mathematics because and all that. So it is more than likely. I mean, I'm not making any claims, but
Absolutely, absolutely. In fact, the Jesuit story itself, is documented in great detail, is very fascinating because we have the, there's all these things where the Jesuits come back to Europe. What they brought back to Europe is not very clearly documented. Some of it we know in terms of the calendar system, but other mathematics is not clearly documented. But suddenly Europe starts inventing and discovering this mathematics without any sources being ascribed. So you look at the period, it's like if you've thrown a rock in the water, how do you know you've thrown a rock in the water? Because you see the ripples, right? So you see the ripples of what has happened after the Jesuits come back, because you go back 20 years, 50 years before the Jesuits came from India, and you don't see the continuity of mathematics that these later mathematicians are building on. But suddenly they have this flourishing of mathematics, which they all claim to have now newly discovered, without any back history of that in Europe.
it is just like the Greek miracle. This thing,
Right.
like the Greek miracle, like the same thing. Like a miracle, it just springs up from the European genius.
Absolutely, absolutely. Yeah. So suddenly all this knowledge gets ascribed to Greeks, gets ascribed to Europeans, and there is a whole table, if you look in the book, of all these theorems that we later on say are coming from from European mathematicians, whether it's Pascal's triangle or Fibonacci sequence, or a whole bunch of that. If you look at the book, we have a whole table, that Bhaskar has created. All of those that we know actually came from Indian sources but were ascribed to Europeans later on.
Thank you very much. And it was certainly a very nice talk, and I really enjoyed it. And I'm a physicist, that a theoretical physicist, and so I have inherent interest in mathematics also. Now, Bhaskar has really done a wonderful job, say, in bringing the history of ancient Indian mathematics into the right perspective. Now, what I just wanted to make a comment, it's more a comment than a question, that what has happened, say, in the ancient, what has happened to our ancient mathematics, or say to some extent even science, also continued to happen even in the modern era. I want to just give you an example of the invention of radio. We know that all the credit for the invention of radio goes to Marconi. Okay, and today everyone knows that it was Marconi who invented the radio. The real the credit for the invention of radio has to go to Jagdish Chandra Bose. In fact, much before Marconi demonstrated the communication with radio waves, he did so in Calcutta. And in fact, so that was a public meeting, okay, and where he demonstrated the existence of radio waves and how we can even make use of control waves to send the messages. Well, so now not only that, some of the inventions, the related inventions of Jagdish Chandra Bose, which he did in the so-called the coherer, and then use of that along with the telephone receiver. Okay, so now it was that made the Marconi's communication experiment a success. Okay. And that is how the radio really came. This is never told. This is never even in the books. But it is a fact. It is documented. And in fact, I even wrote some articles on that. It's also available in the books as documents. What I wanted to say that what really happened with ancient mathematics in our India. Now, perhaps similar thing also continued in, even in the modern era, so-called when it came to this evolution of modern physics. Okay. So I think we really need to be careful about that. One reason was that Jagdish Chandra Bose, I mean, he never, I mean, patented, I mean, his discoveries or inventions. Okay. He just said that whatever knowledge has been gained, I mean, that must go to the world free. And that is how it happened. Perhaps we may have to, I mean, think along these lines. So, I mean, the right credit goes to us for whatever we do. Thank you.
Interesting point. Even in the case of Satyendranath Bose and the other Bose who discovered the bosons, even Einstein was about to take the credit for that, but somehow in the last moment, it also got credited to Satyendranath Bose for the bosons in physics, the particles. So the similar story is there also with Satyendranath Bose. It's interesting that such kind of things are going on also in modern times. Maybe it's a case of power equations.
Dr. Kamble, I just wanted to mention that I'm sure you must have seen this. There's this book by Matt Ridley. So here they are on, this book is called How Innovation Works. So here, in fact, now the Western authors are also agreeing that what Al-Jaber had written was basically, captured from what he had learned from the Indians. So here on page number 152 and 153, he covers that. So in fact, I like you mentioned, in our education, we never come to know about the greatness of our culture. We come to know of it from the Westerners also. So I also came to know of it from these books only. And the other thing, sir, I wanted to ask you, of course, I'll be reading your book. It is said that Pythagoras traveled to a Gurukul in Kanchivaram and he learned his mathematics over there. So is this also covered in your book, sir?
Well, as far as this exact detail of his going to Kanchivaram, I have not come across that.
Okay.
But I have, for sure, there are legends associated with him that he went east as far as India. But of course, I don't have any concrete proof of that.
Okay.
What I can tell you for sure is that his philosophy was entirely, very much similar to the Hindu philosophy. So he believed in reincarnation, the cycle of birth and death. He believed in the theory of karma.
Yes.
He and then later Greek philosophers also like Socrates and Plato. And he was a vegetarian.
Yes.
And so
yes.
Yes, and then so this of course makes it possible that he may have been to India, or maybe some Indians had traveled to somewhere and they had met somewhere else. This could be. So this is and of course, the mathematics of the theorem is so-called Pythagoras theorem is there in the Sulba Sutras, which are part of the
That's
Vedas.
Right. Yes.
So the philosophy comes from the Vedas. The mathematics then also has to come from the Vedas. If he has indeed discovered, if he's indeed if he knew the theorem at all in the first place.
I guess I've had this question in my mind that there are so many famous people in the West across the decades and eras, across disciplines from philosophy to psychology to sciences, mathematics, who have referred to our texts, learned from there, built their worldviews, and then they have openly accepted that they have learned from there. So I understand that in those societies, Anglosphere and the whole of the West, the education and social policies must be making it hard for people to know that this is where the sources are. But from the famous people who knew about this, people want to read about their biographies. They want to know what their sources were. Where did they learn things from? In the bargain, wouldn't they have learned through word of mouth that, oh, there are these Indian texts from which such a plethora of people across disciplines have been learning? How did that not happen? How is it still so known to such few people, few and far between in the West? Did that at all come up as a question as you were writing your book? And do you have the answer for that? Because that's a burning question I've had.
Yeah, why people don't know about it, right? This is the question, I guess. Why people don't know about it. If I understand your question, that is in essence, that's what your question is.
Yes. But I mean, the normal population don't know, even though they know all these famous people, but they don't know where these famous people got their ideas from. even though the famous people have credited our texts. That is confusing to me.
Yeah, so I think that it's I think, for one thing, I mean, maybe there are many issues at play here. One thing could be that people have heard of, let's say George Boole, for example, yeah, who is credited with the discovery of the development of Boolean algebra. But how many of them know that he was deeply influenced by Indian logic systems, Indian philosophical systems, right? Then how many of those people know? So it's like, one has heard the names, but it's only a very small minority who would take the time of studying their works, maybe specialists, and then they would come in touch with their sources. And so I think it's definitely not to be expected that just because they have credited it follows that the general public will know about it, because the general public will get its information from mainstream media, from word of mouth, from
Textbooks.
Textbooks, school education, exactly, journalists. So in school, I never learned about the things which I learned only later on my own. So I think it definitely does not follow that people would know about it. I mean, there are many reasons for that, right? I mean, there is this the tendency during the colonial times, this Western, that everything comes from the West, from Greek mathematics. Many people believe that. So one just has to. I guess the reason is that these prejudices are still there, and colonialism in some way or the other lives on. This is what I would say. If it answers your question, yeah, maybe I'm wrong. Maybe there are also other factors at play that could well be, but this is how I would. Maybe
Yes,
Sankrant,
yes.
we have to,
Yeah, it does answer my question. I guess people don't look beyond, well, where did Schopenhauer understand what he did? Where did Oppenheimer understand, or where did Kant get his views from? People just hear
Right. What has happened is that there's a small, like we are discovering it, and there is a small number of people who are becoming aware of these things. But the big mainstream disseminators of information, whether that be the textbooks, in India or abroad, Indian textbooks are unfortunately no better in terms of crediting mathematical sources. Or how the media covers it. The media still has displays so much contempt for the Hindu civilization, again, whether in India or abroad. So even though we have all these, Bhaskar's book itself shows how Babbage and Boole, my field is computer science. These are the people who really invented the fundamentals of modern computer science. They were deeply influenced by Hindu ideas, and they studied the Hindu text. And Mary Boole actually credits Hindu ideas for their discoveries. But again, you wouldn't see that in any major mainstream textbook or anything like that.
So I add here that it's about rewriting history. I mean, in the sense of, history is written by the victors. So this is the sort of thing which one has to also keep in mind.
That was a wonderful revelation to us. So many things. So, and just taking forward from the previous question, do you think it will be a good idea to introduce the history or the origin of these terms of calculus and trigonometry and all at the school level, 10th, 11th, when it is just introduced? If the students get to know.
For sure. I mean, I would not recommend having an extra course for that, because they already have burdens. But in the textbooks, it can be, mentioned, and for sure, one should also emphasize these things like the transmission of calculus from India to Europe. I mean, this has to be emphasized in textbooks and mentioned, and
both the mathematics textbooks don't mention it. They only give European sources and origins. Neither do our history textbooks mention the history of Indian science or mathematics. In fact, Garuda has taken on a big charge to. We have also published a book on a brief history of science in India, which is talking about all the scientific discoveries that happened and we don't know in a mainstream textbook. So Yeah, absolutely. I think the getting it into the textbooks is very, very crucial. It doesn't have to be a separate subject. It can just be woven into the history that we have. I mean, we don't really need to study some of the other useless history that we are studying, rather than, who invented basic, foundational ideas of mathematics and science.
Yeah, it could definitely be a part of history syllabus, and in math syllabus, it can be a little bit, in the like extra information kind of sections in the textbooks. Um, but yeah, it has to be part of the school syllabus for sure.
Yes, and also since this communist Marxists had taken over our education, I mean, they didn't want anything to be credited to the Indians. And so they completely whitewashed the background and they only pass on whatever. I think, I mean, I grew up not knowing anything about my culture and this, because my history books and my maths and everything, they all taught us Euclid and, Pythagoras and all these things. So what Sankaranji said is the mainstream. When it doesn't peddle that to you and you don't know the background, then you probably don't know what influenced them. And our education is also not like that.
Yeah, because as a school child, one has blind faith in what the teacher is saying and what the textbooks are saying. So if they carry wrong information, one will just accept it as true. And till adulthood, one just accepts that without questioning.
Or either you are in a family which is very literary and likes to read, and they have like a cosmopolitan understanding, and they know the background and they pass that on to their children. I mean, because it was all taken over by the colonial people, and printing press was also something which was very exclusive to a certain section. And so I think there are many reasons why we never knew. I mean, it was just them and what theories they gave. Nothing that inspired them. So
it's actually also interesting what you mentioned about this communism and Marxism, because they have this nexus with the one of the one of the things that I mentioned in my book is also like this, how this Islamic invasions in India, they had a devastating effect on the history and on the development of the civilization. I mean, they just destroyed the civilization totally. And even Al-Biruni mentions that, where Mahmud al-Ghazni, he destroyed the city and Indian sciences retreated. So unfortunately, the Marxist historians, they look upon these Islamic invaders as some kind of heroes. And so anyway, so this is also one point which comes up in the book.
Yes, and we also know that there are a lot of foreign forces that still don't want us to know about our glory, but thankfully Sankaranji and people like you, Bhaskarji, are bringing that forward, and I think that's why we need to encourage these kind of publications.
Say just a small request and a small comment. Okay, now it's I have read Dr. Bhaskar's book. I immensely enjoyed it. Okay, and and I was really surprised the amount of research he has done. But for every statement, I say he's giving a reference, and that is something fantastic. Now, another thing, say it is written in a very lucid manner, which one can read so easily. And but then the question is, I mean, say that of publicity. How do we give publicity? How do people know about the book? Okay, so that such a nice book has been say written, it's available, say, which puts our theopathitis in the right perspective. I think some publicity from this of Garuda publications itself is required, not only in India, but also abroad, especially in the Western countries. Okay, so I think if some reviews of the books could be published, either in India or even in the Western media, I think the book will get a lot of publicity and then people will come to know about it. And it will really help to bring our history into the right perspective. I mean, the history of mathematics is also history of science. Thank you.
Absolutely, Vinayji, I can respond to that. Garuda is, of course, publicizing it to the extent that our resources allow, and we are able to do it. But I view Garuda as all of our endeavor. It doesn't belong to any one person. It's really a civilizational initiative. So Garuda flies on your blessings. It flies on all of our cumulative effort and work. So please, whoever is able to, in whatever way, if one can spread it on social media, one can write a review, one can tell your friends, one can write an article. Please be part of this movement so that we can decolonize the Indian mind and also bring our wealth to the world.